So that's done. In terms of some definitions, real quick. So when we start talking about a perfect square or a perfect cube, what you're going to put down for the definition of a perfect square, it is the product. So we're going to be multiplying a rational number by itself. Oops. Let me try that again. Itself. All right, so a quick little example. If I gave you 2 times a 2, that's a rational number multiplied by itself. So the number 4 is what we would consider a perfect square because we got that via a number multiplied by itself. All right. So that's why when you see our list of perfect squares down here, you're going to see the number 4 listed because we got the 4 by doing a number by itself. And in this case, it was a 2. All right. So before we do a perfect cube, we're just going to fill out this little table real quick so we understand what this is now saying. A product of a rational number by itself. So the reason number 1 is a perfect square is because I can do 1 times 1. And then the example that I put up with that little definition, the reason 2 is considered a perfect square because it's a 2 times a 2, and then that's how we get our 4. So anytime we can do a number multiplied by itself, so 3 times 3, 4 times a 4, you probably don't necessarily need to fill all of these out. I would hope we know these things at this point. The big thing you want to understand, these numbers over here, the 25, 36, 49, 64, these are all considered perfect squares because we're getting them by taking a number and multiplying it by itself. So whenever we refer to a perfect square, we're talking about those numbers on the left-hand side of the column, and their factors are the number multiplied by itself. All right, and you'll need to know these very, very well. I think I went through 15 here, so just make sure we know through 15. All right. Now, a perfect cubed is also a product of a number and itself twice. So what that really means is 3 times, right? Like if I took a number, so let's say 3, and I multiply it by itself 2 more times, so 3 times a 3, the idea of a square means 2, the idea of cubing something means 3, so now I just have the same number multiplied by itself 3 times. So if you think about what is 3 times a 3, that would initially give you 9. But if I did another 3, that's a 27. So that's why you're going to see this 27 in your column listed as a perfect cube, because that's what we get when we do 3 multiplied by itself 3 times, or three 3s multiplied by each other. The reason 1 is a perfect cube because I can do 1 times 1 times 1 and still get a 1. The reason 8 is a perfect cube is 2 times 2 times 2. Those would be the 3 most common, the 3 most obvious. You can see we can't go too big because these get really big really quickly. But if I did 4, 4, 4, that's a 64. If I do a 5 times a 5 times a 5, that's our 125. And then 6 times 6 times 6 is 216. And the last one I probably would make you do, but we're not going to go bigger than this. It becomes pretty tricky, some pretty large numbers. 1,000 is the product of 10 times 10 times 10. So those are what we call perfect cubes. And you will need to know those pretty well, especially the square roots we're going to do a ton of. All right. All right, the multiplication property of radicals. In terms of what a radical is, when we use the word radical, it's just a different word for a square root. Last year you dealt a little bit with cube roots. You would dealt a little bit with a 4th root. Those are things that you talked about briefly. And then obviously we're going to get into them a little bit more. So a radical is just one of these things. Anytime we have a root, square root, cube root, or a 4th root. The multiplication property, if we do it with variables, just means if I have like a root x times a root y, as long as they're both square roots, then we just multiply the numbers underneath them. Now, let me do these with numbers. I think it's a little easier for you to kind of see with a number. So think about if I gave you the square root of 7 times the square root of 2. Since those are both underneath the square roots, we can just go ahead and multiply those 2 numbers and then still leave them underneath the square root. All right. Now, One more example. Let me do this one in red so you can tell the difference. Let's say I gave you a 2 root 2, and I multiply that by 3 roots, we'll go 5. So that we get too complicated just yet. Notice how we have a couple numbers out in front. So the 2 is out in front and the 3 is out in front. So we're going to multiply those guys together, and they would remain out in front. We also have some numbers underneath. So this 2 and this 5 are underneath, so we can multiply those together, and since they were initially underneath the radical, that product remains underneath the radical. All right? So that's some of the properties, what these will look like as we start getting into them. And then the last one, what we're really going to focus on a lot today, simplifying a radical. So if I ever tell you to simplify a radical, which we're going to do a bunch of here in a minute, what that basically means is no perfect square. And by perfect square, what we're talking about by perfect squares are these guys up here, right? This is what we just defined as a perfect square. No perfect square, at least for a square root anyway, can be left under the radical. And the radical, again, is really just that root symbol, the weird kind of, this guy here, that weird square root. We cannot leave a perfect square underneath that square root. If there is, we need to do what we could say is simplify it. All right, so now here's what this means too, because this is now what we're really going to be doing here the rest of the period, is just simplifying each radical. So for us to simplify a radical, it's nice and big here. If we look at this 75 right here, what we cannot do is leave a perfect square underneath this. So calculators are probably good with this, something you probably would be using in your quiz and a test, because what we have to understand is there is a perfect square factor that we could use to get a 75. So what I mean by that, write out 2 different square roots and say that we're going to multiply those together. And what we're then just using is this property up here. So how do I multiply radicals together? So the numbers underneath get multiplied together to get a new number underneath. What we want to come up with is a way to multiply to get 75, with one of them hopefully being a perfect square from our column up here. So if you look at this 25 right here, right? 25 is definitely a factor of 75. So what I'm going to do is I'm going to say this is 25 multiplied by 3. So if I did 25 and 3, I get a 75. So a root 25 times a root 3 would give us a root 75. That you know this, we deal with it a little bit in Math 1. I know you do this in junior high as well. We know the square root of 25, right? We don't have to plug that into our calculator, hopefully. The square root of 25 is 5. All right. So if we go up to here, any of these numbers I can do the square root of. The square root of 100 is 10. The square root of 25 is the 5. The square root of 9 is the 3. All right, it's basically asking you what number did you square to get that. So in this case, we get a 5. But if you look at this 3 here, is 3 listed as one of our perfect squares? No. If I ask you what did you square to get a 3, that'll keep you busy for a while in terms of what number could I multiply by itself to get a 3, and there isn't one. So because of that, there is no way for us to simplify that 3. You're just going to leave that underneath the radical. So this here is your simplified answer, 5 times the square root of 3. There's nothing we can do with the 3. All right. So now the second one, if we look at 8, what we want to come up with is a way to multiply to get 8. And we want to see if any of them is a perfect square. And this is pretty obvious because 8 is not a very big number, so you don't have to explore very much. It's got to be the 4, right? Like a 4 times a 2 is going to give you that 8. Then we know the square root of 4. At least I hope we know the square root of 4. It's just asking you what number did we square to get 4, and that has to be a 2. But if we look at a 2, the term that's left over, if we go back to our list here, notice how 2 is not listed because 2 is not a perfect square. There's nothing you squared. And again, if I ask you what did you multiply by itself to give you a 2, that will keep you busy for a while in terms of trying to come up with that. So there's nothing we can really do with that, so we just leave it as a root 2. So it's 2 root 2. All right. As easy as they get, number 1 and 2. Same with number 3. See if you're understanding, because while they're easy, these are new to you, so that doesn't necessarily mean they're easy to you just yet. But if you understood 1, you kind of understood number 2. Number 3 is very much in that same mold. All right, so what we're trying to do, what 2 numbers multiply to be 27? One of them we are hoping is a perfect square if we can simplify it any further. All right, what do you got there, Jenna?
The square root of 9 and square root of 3.
Good. So she picked the 9. The 9 is your perfect square that's listed above in our table. 3 we can't do anything with. So this here should become just a regular 3. The square root of 9 is a 3. And then the root 3 we cannot do anything with. So we just get a 3 root 3. All right. Any questions on that one now? Because those 3 should be pretty obvious what your perfect square is. Now take a second and see if we can do 4. So it's a pretty big number, so there's a reasonable chance that we can come up with 2 numbers that will give you 128. And we want one of them to be one of our listed numbers up here. All right, so see if we can come up with a couple factors, with one of them being one of these guys, that would multiply together to give you a 128. And if you get it, let me know. This is one we want to explore a little bit more. Hold on. I know. I see a few of you raising hands. Just hang on a second. I want us to play around with this one a minute, okay? All right, Ahmed. I saw you first, Ahmed. What'd you come up with?
16, square root 16, and square root 8.
All right. So if you go to your calculators right now and do 16 times 8, let me make sure of that one. That was not one I was thinking of. So that would be, okay, that would be good. Is that what you had, Cam? Because I'm going to guess you didn't. What did you have, Cam?
I had the square root of 64 and the square root of 2.
Anybody get something different? Because there's definitely one more out there that I would think. Yeah, Nora, what do you got, Nora?
I got square root of 1, square root of 2.
Good. So don't all 3 of those.
Works.
What's that?
I'm saying either way works.
Okay.
You have what square root and equals to 128.
Good. So this is why I wanted you to play around with this a little bit, because Ahmed is half right in the sense that all 3 of those will multiply to give you a 48 or 128. So all 3 of these different combinations are going to give us this. Let's say we go ahead and do this first one. So I think Ahmed gave me this. So our perfect square in this one is the 16. We know the square root of 16 is a 4. And then the root 8 is not listed in our list above, so we can't say we know what the square root of 8 is. There's no number you can multiply by itself to give you an 8. It's not a rational number. All right, let's say we go to the second one. Our perfect square in this one is a 64. So that's going to be an 8 root 2. Square root of 64 is 8. And if if we go to the last one, the 4, that's going to be a 2 root 32. All right. Now, we still want to make sure these are completely simplified. So think of it like this. Let me come up with something. Let's say I gave you 28 divided by 16, and I ask you to reduce that. So if I said to reduce that, couldn't we reduce both of those by 2 and get this to be a 14 over an 8? We've reduced it, right? But is that completely reduced? No, because I can continue to do that again by a 2, and now I'm going to get 7 over 4. That's completely reduced, correct? So what that actually means is we could have done this in one bigger number right away by dividing by a 4 and get the 7 over the 4 right away. But we want to be completely reduced. So this version here is our completely reduced version. That's our final answer. That doesn't mean the other two are wrong. Here's what you would now have to understand. I'm going to rewrite this 4. And can't I break down 8 further? Didn't we already do 8 up here as a root 4 times a root 2? So you would have to recognize then, and this is going to happen to everybody, I guarantee you, that you're going to be able to do these a little bit further. Well, what is the square root of 4? If I just ask you, what is the square root of 4? Isn't that 2? So don't we really just have a 4 times a 2, which is 8, and then I would get that root 2. So the same exact answer if we picked a different set of numbers. If we go to the next one, so now let's go to the one down here that's not completely simplified yet. The 2 is all set, but then think about a 32 here. And we want to pick the biggest numbers, and here's sort of the key. We want the biggest numbers possible. A 32 I could get with a 16 and a 2. What I really have then is 2 times, what is the square root of 16? What do we square to get 16? 4, right? So isn't this really a 2 multiplied by a 4? Oops. Which is 8, and then the root 2 would stay the same. Now, aren't all 3 of those the exact same answer? Yeah. So here's a lesson to be learned. If we can pick the biggest number possible, that's the best route. It's the simplest route. It's the easiest route. If you don't pick the biggest number, so you get here, we can absolutely still get to the final answer. You just got to recognize that we need to make sure that we're going all the way in terms of simplifying that. Okay? And I guarantee you this is going to happen to you a lot. So ideally, you're going to get the biggest one, and then that's going to be the best route to make this easier. Okay? So let me see here. I actually want to find one that hopefully plays out similar to that real quick. Nah, darn it. All right, go to number 5. Go ahead and try number 5. I don't know if there is another one. Yeah, see what you think for number 5. What's a number? I can't come up with one of these off my head. It's overthinking it, I think. All right. Like number 4, where I wanted you to play around with it a little bit because there were a bunch of different ways to get number 4, and we came up with 3 of them. Number 5, I again kind of wanted you to play around with and see if we can come up with it, because this is now the opposite, right? There's not a lot of ways to get a 30. Here are the ways we can get a 30. We can go 6 and 5. But if we go to our perfect square list, so if we come up here, are 6 and 5 listed as a perfect square? No. So that's not going to work. Some of you may have used a 3 and a 10. That will give you 30. But if we come up here, the 3 and the 10 are not listed in our perfect squares. The last route you could have taken is a 2 and a 15. But same thing. If you look at your list of perfect squares on the previous page, there aren't any. So you are going to get somewhere. This is simplified. And if I put this on a quiz or something, this is what you would just tell me. It's already simplified. There's no further route we could take to break that down any further. All right. All right, 6. See if you can come up with number 6. Looks big. This one you'll actually like, though. I think this one we will get. Should not be too hard. What two numbers multiply to be 405? It's not a trick one. It's not a simplified one. Okay, I just gave you that one so we can kind of see that that does happen from time to time. This one is not simplified. You can definitely come up with a couple numbers that give you 805 or 405. All right, got one, Cam? What do you think?
Square root of 81 and square root of 5.
Anybody else come up with something different? Good. I mean, you could do a 9. That would work, 9 and 45. But the 45 is pretty big. So like if I did a 9 and a 45, that would work. And this gives you a 3 root 45. But then you have to understand, this can be broken down further like the one that we did a couple of minutes ago. So if we can go big right away with the biggest number possible right away, which Cam has come up with, then this is much quicker. What's the square root of 81, Cam?
9.
Good. And then root 5 we can't do anything with, so you're just going to get a square root of 5. All right. All right, next ones. Now kind of get into what we were dealing with here a second ago when we simplified these. Here's your square root, and it's getting multiplied by a 4. So we're just going to drop that 4 down. And then we have to come up with ways to get an 18. So like 6 and 3 would work, but 6 and 3 aren't good numbers. They're not a perfect square. So what we would want to come up with is 9 and 2. Those are our perfect squares that give us an 18, or at least one of them is a perfect square. And then all we now really have, we're multiplying together. And if you want to show this stuff, and I might here in these first two, this is really 4 times a 3, right? Because the square root of 9 is a 3. If you can do just 12 right away, feel free. But now we definitely do the 4 times the 3 to give us a 12. And then that root 2, there's nothing we can do with it. All right. So number 8, same thing. We're just going to drop that leading coefficient down. And then be careful with this now. I want to make sure we do a cube root or 2 next. So I want to kind of make sure we do this. This is really, really, really easy. So don't write this down right now. To put, let me do it in a different color so we know we're not going to write this one. It's really easy to put 4 and 20 because 4 is a perfect square. It gets you started, but notice how that root 20 can go further. And ideally, we want to get the biggest possible perfect square right from the beginning to make our work the easiest. And the biggest number that goes evenly into an 80, that's also a perfect square, is 16. And it would be 16 times 5. So what we really then have is this 2. I'm going to continue to drop that 2 down. It's now going to get multiplied by a 4, because that's what the square root of 16 is. And then the root 5 is nothing we can do with it. So our final answer is a root 5. All right. Okay, last couple. We'll show you these. This won't be a big emphasis for what we're going to do, especially early. If we go back up to our table, so when we did these, notice how now the square root of 9 is asking you what 2 numbers did you multiply together to get 9, and it would be a 3. The square root of 25, what 2 numbers did you multiply together to get a 5, and it would be 5. If we now go to the cubed root side, If I ask you for this, I put this radical in here, and now I put this, what we call an index number, and it's a 3. That's a cubed root. That's now asking you what number did we multiply 3 times together in order to get 27. Notice how it's 3. So the cube root of 27, we would say, is 3. If I ask you what the cube root of 64 is, the number that got multiplied by itself 3 times is a 4. So we would say the cube root of 64 is 4. So on and so forth. So the cube root of 125, since it took 3 5s to get 125, the cube root of 125 is 5. So when we now go to these problems down here and I ask you to simplify them, it's the same thought process, but now we want perfect cubes. All right. So if I go to the cube root of 250, I'm going to, again, multiply 2 of them together. The only real factors we're trying to come up with here are the numbers that are listed in your table as perfect cubes. So if we go back to our table, we really only want to be playing around with, I don't move it too far, these numbers here. All right, so the one I'm going to use, just make sure we get some of these done. I'm going to use a 125 for 250, right? The cube root, or 125 is a perfect cube. So if I go back to that problem, we're going to use the cube root of 125. So 125, and then that would have to get multiplied by 2 in order to get 250. So then what you're thinking, what number did I multiply by itself 3 times in order to get a 125? If you look at your table, it's a 5. So the cube root of 125 just becomes a regular old 5. And then we cannot do anything with the cube root of 2, so then that stays the same. All right. Number 10, cube root of 81. So if we look at our list of cube roots, perfect cubes, and again, I'm kind of speeding through here so we can see a couple of them. What we would want to use here is 27 and 3. 27 times 3 is 81. And the reason we want to use 27 is if I go to my list up here in our table, see how the 27 was gotten by multiplying 3 times. So the cube root of 27 is a 3. So if we go back, that becomes a 3. And then the cube root of 3, there's nothing we can do with it. All right. Last one real quick. Go to number 12. This would be the cube root of 8 multiplied by the cube root of 5. 8 times 5 gives you 40. If you went and looked at your table, we're running out of time, so I won't do that, but the cube root of 8 was gotten by taking 2 times 2 times 2. So the cube root of 8 would have to be a 2. And then the cube root of 5, can't do anything with it. All right. Okay, so with that, we should be able to do the homework. So the homework is either right here. If you have the packet, it's in the packet. It's just 3.2 day 1. And if you have, go to the assignments, you can find it there also. All right. Okay, with that, we'll see you guys for the bell. We'll see you guys tomorrow. If you have any questions, let me know. On your guys' homework packet, by the way. Only you get one. Yeah, just make sure you get one. Stop this recording.